Since this question was not completed, so we are going to complete it now. For the third part, we have seen the first two parts as shown it here. So you can recheck the answers. And now we are going to solve the next part of this question. For the motion from B to D, the driving force of the lorry is constant and it is equal to 7,200 Newton. From B to C, the resistance to the motion is constant and equals to 1240 Newton. And from C to D, the resistance to the motion is 860 Newton. Given that the speed of the lorry at D point is 7 meters per second, find the distance BC. So since these two parts were already completed in the videos, so we are going to solve this next part here. Now, we know one thing from this part, that it is covering the distance with the two resistance forces are there. One is from B to C, which is 1240 Newton, and other one is C to D, that is 1860 Newtons. So we are again going to apply the rule first, that work done by the driving force minus work done by the resistive force is equal to change in kinetic energy of the system plus potential energy of the system there. We can have another method there, but we will first use this part and you will find out the distance from B to C. Since the total distance from B to D we have already calculated equal to 300 meter in the last part. So let's say this distance is x and this distance will be equal to 300 minus x, because it is covering the distance in the two different phases, one from B to C and other is from C to D there. Now, with the help of that calculation, we are going to make it, let's say this angle is theta there, and this total height is h there. So work done by the driving force, that is driving force, basically work done by the driving force is equal to driving force into the distance. So driving force here is 7,200 Newton into the distance from this B to D is 300 minus the work done due to the resistance, because there were two resistance. One is from B to C and that force is equal to 1240, and the distance between these 2 points is, let's say, equal to x, plus this 300 minus x into the force there is 1860. So this is the total work done against the resistance there. One is in the first part and second one is the next part from C to D. That thing is equal to change in kinetic energy, that is half mass of that lorry is 16,000 into the speed at the point D is 7 minus speed at B is 12 plus mgh, the mass of that particle is again 16,000, g is 10 into the height, which can be calculated as h over 300 is equal to sine theta, or h is equal to 300 sine theta, or that is 300 sine value theta is 1 over 20. So h value is basically equal to 15 meters. So into 50. After doing this calculation of this equation, we can find out the value of x is basically equal to 61.3 meter. And this is the distance of BC. So we can use the other method for the same question, where we will use the concept of the velocities. From B to C, we know that we don't know the velocity at C position there. And we can calculate with the help of this formula, driving force minus the resistive force is equal to net force. But since the driving force here is 7,200, so we can write this thing as 7,200 minus the resistive force to that particle, that is from B to C is 1240, plus, because we know that when it will move from B to C, this is the components of that. So mg sine theta is also working for that part there, where m is basically equal to 16,000, g is 10, and sine theta is 1 over 20. That thing is equal to ma. So mass of that particle is again 16,000 into acceleration a there. So we will calculate the acceleration as equal to 7,200 minus 1240 minus 8,000 divided by 16,000, and that value is equal to minus 0.1275. So we know from this equation V is equal to U plus AT. So V at C is equal to U, that is given there, which is the speed at B, that is equal to 12, plus acceleration there is minus 0.1275. Instead of using this, we can use this part, V square minus U square is equal to 2as, because time was not mentioned there. So we are going to use this equation of motions. So velocity at C there minus at U, it is basically equal to 12 square is equal to 2 into acceleration is minus 0.1275 into the distance s there is x. So we can calculate that VC square is equal to 144 minus 2 into minus 0.1275 into this x. Let's say it is equation number 1 of this part, that velocity at C is to be this value there. Now we will calculate again from part from C to D. We know that the velocity at D position is 7 meters per second. So we can have the same calculation here. First, the driving force minus resistive force is equal to net force MA for this portion there. So first we will calculate the acceleration in this part from C to D. We know that driving force is 720 from C to D. Now we are going to calculate. So 7200 minus the resistive force to that motion is 1860 plus the frictional force, again the same part from, let's say it is B, now let's say it is at D. So it should be equal to mg sine theta, which is being calculated there, equal to 8000 is equal to mass of that particle is 16,000 into acceleration A there. So we can have this value of acceleration there, 7200 minus 1860 minus 8000 over 16,000, and the value of A is equal to A value is minus 0.166 meter per second square. Now you can calculate the speed at this D position. We know that velocity v square minus u square is equal to 2as. So velocity at D, that is 7 square, minus velocity at C, that is we don't know. So we calculate it as v of C there is equal to 2 into acceleration is minus 0.166 into distance s there, that is equal to 300 minus x. So v of C square is equal to 49 minus minus plus 2 into 1.166 into 300 minus x, and let's say that is equation number 2. Now we can solve this equation number 1 and this 2 simultaneously, because both of them they are equal to Vc square. So final equation will be equal to 144 plus 2 into minus 0.12575 into x is equal to 49 plus 2 into minus 0.166 into 300 minus x. And after doing this calculation, we can get the value of x there, which is basically equal to 61.3 meter for this part of this question there. So you have seen it there that we can solve it with the two methods. One, directly with the help of this work done by driving force minus work done by resistive force equal to change in kinetic energy plus mgh, or you can solve the two different equations and you will get the two different accelerations for these two equations from B to C and from C to D. And then you can put in the velocities equation and you can solve them simultaneously and you will get the values of x there. So this is the final solution of this problem for this question number 16, and we have solved it in two parts. So where there is any confusion, write the comments for that question or any other question which you don't understand directly.